Alright everybody, excuse my really messy desk, but this is what it looks like when you're developing something. Anyways, today I've got a new project. This is what I'm calling the DataTalk 3000. Why 3000? I don't know, it was a cool number. Anyways, so this device is a telephone monitoring system. Well, or rather, I don't like saying telephone monitoring because it's not monitoring the telephone. It is site monitoring via telephone. So anyway, so what it does is it takes some data input and it allows you to, it'll tell it back to you over a phone line. So here it is. It's in a homemade rack case, which is actually too tall. So technically it's not 1U, it's like 1 point, I don't know. Anyways, the specifications for 1U is that it's 1 and I think 3/4 inches tall, I think, or maybe 1.5. I don't remember. Anyways, this is just like a 1/4 inch too tall. But anyways, that doesn't matter. On the front panel here, we have a busy LED, and in this homemade metal enclosure here, we've got the PCB itself, and on the back, we've got a, as you can see, we've got a terminal or a barrier strip. So in here, featuring the best of components, we have, actually let me just point and I'll show you, because it's kind of complicated what we got going on. We have a 7805 voltage regulator. Over here in the corner we have a DHT11 temperature and humidity sensor, which is not accurate, and I don't know if it's my code that's not accurate or if it's because it's right next to this component here that might be heating it up. That might be why the temperature is not that accurate. But anyways, right here is the Atmega 328. I have an MT8870 DTMF decoder, a NE5532 op amp for the mic preamp. Here's a 1-to-1 isolation transformer, reed relay, opto isolator for ring detection, and a bunch of passive components. And right here is a micro SD card reader. I was actually going to just have all the audio raw encoded into this, but that won't work because there's not enough storage on there. So I could do it and have a couple samples, but currently I'm sitting at like 60 some audio samples, and that would not fit on that little microcontroller. So currently the micro SD card is what I had to go for. And then to program it, as you see, there's a little jumper back here. Since I have to program this via ICSP in line or in circuit, I have to take this jumper out because this also uses ICSP. So anyways, let's go ahead and just kind of talk about how it works. What happens is when you call into it, it'll ask for a password, and that's configurable. Pretty much everything about it's configurable. It'll ask for a password, then it'll tell you the temperature, humidity if you want. It'll tell you the status of both the inputs/outputs, and it'll let you listen to a room monitor, because on the back is a little tiny electret microphone, and yeah, because in data centers and stuff, you might want to listen to the room to make sure you're not hearing like a squealing noise or something. So I have this pretty much worked out. Right here in the op amp section, this is a, let me zoom in here. This is a, excuse all the, that's not flux, all the, that would just focus. That's not flux on the board, by the way. That is, actually, I guess it could be flux. I was cleaning it with isopropyl alcohol, and that just kind of appeared, but it's not causing any problems. So I'm going to leave it be, because it was kind of a pain to remove. So anyways, basically what we got going on here is the phone line comes in here. This is an RJ11 jack, which isn't in use. I was just using that during testing. But there is actually a surface mount diode underneath this board that's I didn't want to have to remove, so I just left the jack there. But anyways, the ring detection circuitry over here detects ringing voltage. Then it sends it on, it sends that signal to the microcontroller. The microcontroller then enters it by turning on this relay, which connects this transformer, which takes the phone line off hook. Then the signal goes, there's a couple capacitors there, and one of the capacitors is I would consider an input capacitor and one an output capacitor. So one of the capacitors goes to the input circuitry to the 8870 DTMF decoder, and the other one goes to the output of the microcontroller, which is also tied into the output of the second stage of this mic amplifier. So on the mic preamp side, I've got just a two-stage thing going on. There is also, to turn on and off the microphone, down here is a little PNP transistor. That was a test, and I didn't feel like removing that transistor, so this NPN transistor is not hooked up. Anyways, I got this PNP transistor here, and what that's doing is it is basically cutting off the bias to the microphone. So these electret microphones require a 5-volt bias or such, a certain bias voltage. And basically, the Arduino is just cutting off that bias, and when that bias is cut off, there's no signal going into the amplifier, thus making no noise on the phone line. So, anyways, it goes to the first stage, which has a fixed gain, non-inverting amplifier, or I mean inverting amplifier, and then goes to the second stage, which is another inverting amplifier with a non-fixed gain, which you can control here. And it will then amplify it up to, I think, a positive voltage swing of, I think it's 5 volts peak to peak. I'm not 100% sure what the, it's probably not that high actually, probably about 2 volts peak to peak, I think, but high enough to make noise on the phone line. Anyways, and that goes through a capacitor into the transformer. Yeah, I mean, I guess that's basically all that's to it on that forefront. I guess I can call into it and stop rattling on. So I've got a phone here, and I'm going to call into it. Now, because of the way my BCM is configured, I actually have to enable long tones for me to pass DTMF on internal calls. So you'll see me do feature 808, but don't worry about that. That has nothing to do with it. It's just to do with my phone system. So anyways, we'll go ahead and call it.
HSL Research, DataTalk 3000. Enter access code. The temperature is 87 degrees Fahrenheit. The humidity is 21%. Alarm. The door is open. Alarm. The AC power is unstable. Listen to room audio for 10 seconds.
As you can see, there is a microphone and it is working, and it's trying to feed back. But yeah, and the busy LED, that's saying it's hung up. Anyways, as you can see, the LEDs return to green. Yeah, this is a bicolor LED. Yeah, there's kind of a clicking that goes on, but that's just because this is not using a DAC. This is pulse width modulation, and I'm pretty sure that clicking is due to the fact that the PCM library I'm using is actually it's kind of weird. It basically, at the sample rate, it runs a timer interrupt. So I think that what you're hearing is some weird timer interrupt stuff happening. Anyways, so yeah, I'm happy with how this is working. And if you heard in it, it said alarm door open, alarm AC power unstable. Now you can actually configure each of those voice messages. But what I'll go ahead and do is I'm going to go ahead and short this. This is on the AC power input. You can actually have these inputs are on the analog pin, so you can configure them as either digital or analog inputs or outputs. So very versatile. You can set voltage thresholds, so you know, if like the analog input is above, I don't know, the value 500 out of 1023, then it will be an alarm condition. If it's below 250, let's say, then it's in alarm condition, or then it's in a normal condition, or whatever. There's a bunch of different configuration you can do to it. So we'll go ahead and I guess just call into it again with the now. I've turned off the or I've basically told it that the AC power is stable again. So the idea here is that you can have like different inputs, like a door contact or a relay that's connected to the AC voltage, or you know, your wall outlet, or if you have a battery backup system, you know, something that's like that's like connected to the battery backup system or whatever. So in this situation, I don't really know what I'm going to monitor with it yet. I just have always wanted to build something like this. And the main thing I wanted was the room monitor feature itself and the temperature monitoring. So, anyways, yeah, let's go ahead and call it. And let's call it now that I've got this sorted out.
HSL Research, DataTalk 3000. Enter access code. The temperature is 87 degrees Fahrenheit.
I don't know why it bursts
The
like that.
humidity is 20%. Alarm. The door is open. The AC power is stable. Listen to room audio for 10 seconds.
Yeah, so you can hear the room monitor definitely works. And you can adjust the gain. The second stage there, where the trim pot is, allows you to adjust the gain. Now that tone is really loud. That's the only problem, I guess you could say, with it. The tone's really loud. So yeah, here's all the programming options you've got in here. You can change whether or not it requires a password for it to announce anything. You can change whether or not you want to announce the temperature. There was supposed to be a humidity one in here, but for some reason that's not in here. Must have skipped over that. Anyways, you can change whether it announces the temperature in Fahrenheit or Celsius. How long the room monitor is for. So right now it's set to 10 seconds. Whether you want it to announce anything for input 1 or 2. Because, let's say you're only using one of the inputs, not the other one, you can go ahead and disable the other one. For example, I'm using input 2 but not input 1. So let's go ahead and I'll show you how to program it real quick, and we'll go ahead and turn that one off.
HSL Research, DataTalk 3000. Enter access code.
There's a separate code for
Enter
programming.
command.
And the command's 6 and then 0.
Enter command.
Oh, 6.
Enter command.
Come on.
Fahrenheit. Enter command.
There we go. Yeah, the programming's kind of weird. I was getting fed up with it, so I just... There we go.
The temperature is 87 degrees Fahrenheit. The humidity is 20%. Alarm. The door is open. The AC power is stable. Listen to room audio for 10.
Okay, well that clearly didn't work, and that's the best time to test something for the first time is on video. The programming side of this was very just thrown together because I've been working on this project for about 4 days now, like all the time. I'm getting pretty fed up with it, and I just wanted to go in the rack. So I kind of just threw this together and was not paying attention. So half of the programming is messed up, but everything else I've spent a lot of time on making the code try to act quite normal and modular. But the programming is kind of janky. But what I was trying to mean is that, I was trying to say it first, hello, is that there's two different codes to get in. One is the regular access code that'll just tell you all the information. The other one is a programming code that will actually allow you to program it. And there is the ability to have digital outputs. It's like if I want to turn on a heater or something or whatever, that would also be a potential output, but I don't have that connected at the moment. One idea was possibly like, what if you got like a place that you need emergency access to, like the door, if it's got like access control or something, you could have the relay output trigger the access control or whatever. Anyways, I think I've been rambling on long enough. Let me know if you guys like this project or others like it. As you can see, this is in a case that was labeled ANA 311. Where I had that project here somewhere on my bench. So I've got a bunch of different projects built up. These are both amateur radio repeater controllers, neither finished. Anyways, this was supposed to be an automatic number announcer. For example, I have this one, but I'm pretty sure it's not functioning correctly. So I'm gonna have to. I was just decided I'd build my own since I figured out how to do MF decoding. Digital signal processing in Arduino. Still got to do some improvements to the code so it runs faster, but That's what this case was originally made for, but I kind of gave up on that project. So, well, I'm glad to get this back into the case, or rather, glad to get it in a case, and it'll be going into this rack over here, where all the telephone stuff is. And yeah, so hopefully y'all enjoyed this video, and let me know if you want me to make anything more like this, or if there's anything fancy, special about it, or I don't know, if you have any questions, just let me know. Alright, see y'all.